The purpose of this video is to show you how provisioning works in vRealize automation with Ansible Tower when utilizing the SovLabs Ansible Tower module for vRealize automation. Ansible Tower is a team-based expansion for the popular open-source Ansible configuration management platform. When used in conjunction with the SovLabs Ansible Tower module for vRealize automation, you can enable provisioning capabilities from vRealize automation while simultaneously providing the ability to manage dynamic inventories and grouping using vRealize automation inventory metadata for ongoing day 2 management via Tower. In our previous video, we covered inventory management. Now let's take a look at provisioning. Previously, we created a dynamic inventory in Tower and used the SovLabs Tower module to define dynamic groups within that inventory based on user, business group, and the like. In this example, we are going to create a new group within that inventory based on applications that we'll control via a single VRA property called appName. We'll start by editing our Tower inventory profile and add a nested group called applications. The nested group will be based on a vRealize automation property called appName. As you can see here, I'm setting a custom property on my blueprint that references appName. Now servers provisioned using this Tower inventory profile will become members of a group that is defined by the value of this property. Next, we'll associate a blueprint with a Tower profile whose default job template will install Apache. As seen here, we're selecting Demo Job Template number 2 in vRealize automation, and if we look at Ansible Tower, we'll notice that this job template is associated with an httpd.yaml playbook. Let's provision a couple of virtual machines, and we're going to verify two things. It will be a member of a dynamic group called Apache that's nested in a group called Applications, and that Apache playbook will run on the server. As you can see, the virtual machines I requested provision successfully. At this point, we can go back into Ansible Tower and verify the group membership of the servers. We can see that the servers are in a group called Applications/Apache. They are members of several other groups per our default inventory profile configuration. As seen here, the playbook that installs Apache ran on my newly provisioned server. We see that it installed the RPM and then started the service. Additionally, if I SSH into the node, I can also see that this playbook ran and that Apache is running. Now, if I scale the server count from 2 to 3, we'll see that the playbook for HTTPD applies to the newly provisioned third node, but does not run for any of the other pre-existing machines in the inventory. That's the default behavior of our module, which filters based on what's actually being provisioned or scaled out versus the entire inventory. This behavior can be overridden in the SovLabs Ansible Tower profile. Now, if we jump back over to Ansible Tower, we can see all the Apache servers that have been provisioned. We can now easily identify and manage these Apache servers directly from Tower. Let's recap. VRA provisioning capabilities. The ability to create a Tower profile encompassing the following capabilities. It can be attached globally to a VRA composite blueprint or to an individual VM component with a 1-to-1 ratio of profile to VM. It can be executed for VMs being provisioned by VRA in context of blueprint or deployment. User selectable or administrator pinnable job template per blueprint via the SovLabs Template Engine with the ability to filter on team and project. The ability to pick one or more job templates from Tower inventory. The ability to specify one or more job templates via SovLabs templated definition, utilizing the SovLabs Template Engine to dynamically render based on runtime VM properties. The ability to override credential selection using credentials defined in Tower. The ability to override inventory, default based on job template. The ability to configure machines to limit job template execution, default limits to machines in a given VRA deployment of a composite blueprint. The ability to supply extra variables as a JSON or YAML formatted string which can include variables given by the user, including answers to survey questions. Extra variables can be templated via SovLabs Template Engine. Supports vSphere and AWS machine types with future support for Azure. Supports single or multi-machine including nested blueprints. Supports Tower's ability to execute on multiple VM components at once by injecting and filtering dynamic inventories or groupings for VMs within respective deployment or blueprint during provisioning. General capabilities. Support for multiple Tower endpoints, inventories, and profiles. SovLabs Template Engine allows for static text in combination with dynamic content such as VRA custom properties and/or custom logic. For more information on these and our other modules, please visit sovlabs.com.